previous lecture, we finished the derivative, the definition of derivative f dash of x, and we find the second derivative also, and we define the definition using definition with the limit, right? We use the limit to find the rules to find the derivatives f dash of x or f prime of x. In this lecture, we will take applications on derivatives. Actually, we'll take two applications. The first one, which is the most important one, is how to sketch a graph. This is the first application on derivative. How to sketch a main form for a graph. So we will sketch a graph of functions. The second derivative, second application will be optimization. We will know what's the meaning of optimization later. So as we said, the outline of this lecture, we will begin. We will describe the graphs of functions using some applications of derivative. To find these properties for the graph, we will use the first and second derivative rules. We will use f dash of x and f double dash of x to find some properties for graphs. Also, we will make the tests of first and second derivative to find these properties. Okay. Second thing, we will take the second application, which is optimization. Optimization problems اللي هي مسائل الأمثلية. رح نعرف معنات الأمثلية بالضبط بعدين when we take it. Optimization means الأمثلية في الحل. This is an important branch of applied mathematics. Okay, the first thing that we will introduce about the graph property is the increasing and decreasing function. Okay, if we have a plane here like that, this is a y-axis and this is x-axis. ما عندكم صوت؟ في أحد غير رسول ما عنده صوت؟
لا تمام الصوت.
لا في صوت.
Okay, check your device. If you don't have a voice, check your device. أو اطلع من الميتينج وارجع مرة ثانية.
دكتورة؟
أيوة.
عندي كويز على الساعة 10:30. يمديني أطلع أختبر وأرجع المحاضرة؟
أوكي مش مشكلة.
تمام شكرا.
لا. Okay, about the increasing functions. If we have a function like that, it's not a line, it's a curve, okay, going like that. If I move from left to right, this is my direction to move. I move here on the function from left to right. I notice that the values of this function is going up like that, right? It's going up. It rises when I move to right. If I have any functions like that, I called it increasing. This is increasing function اللي هي نقول دالة تزايدية. ايش معنى دالة تزايدية؟ معناتها أن كلما اتجهت من اليسار، ضروري هنا الاتجاه، من اليسار إلى اليمين ترتفع قيم الدالة إلى الأعلى. It rises up. Okay? And the opposite, if I have a function like this, notice here, I'm moving from left to right. and the values of the function is going down, falls down. Okay, I call this, of course it's going down, I call this function decreasing function. This decreasing function أو أسميها دالة تناقصية، معناتها أن قيم الدالة تنقص أو تنزل إلى الأسفل كلما اتجهت باتجاه اليمين. ضروري هنا الاتجاه، أتجه هنا من الأعداد الأصغر إلى الأعداد الأكبر، معناتها من اليسار إلى اليمين على خط الأعداد. This function is decreasing and this function is increasing. This is the most important. This is actually an important property of a function. If I know where the function is increasing and decreasing, helps me to sketch a graph easier. Okay, now how to know when the function is decreasing and when the function is decreasing? To find out this property, I will use f dash of x, the first derivative, and I call it the first derivative rule. Okay, before that, I will give the definition of the decreasing and decreasing. Okay, the first one, we will define the increasing اللي هي الدالة التزايدية. Okay, first the increasing, when we call that a function is increasing. Okay, if x is increasing, first let's see the graph. It will be like that. If we have here x1, okay, and here I have x2. Notice here the y component of x1 is here, right? First, notice here on the line, I have that x1 less than x2 من الترتيب على خط الأعداد from the line numbers, right? The left number is the less than, okay, x1 less than x2. So I write it like this. For the y component or the function value on f of x, I have here f of x1, which is exactly here. This is f of x1. And this is the value of x for x2. It's exactly the y component here, f of x2. This is f of x2. Which one is greater, f x1 or x2? Which one here is greater? I begin here from bottom to top. So this one I reach first, yes, f of x2. I reach here first, so this is the smallest and this is the greater, right? This is smaller one. So f of x1 is less than f of x2. This is the definition. This is the definition of the increasing function. If increasing in the in some interval, if I have x1 and x2 and x1 is less than x2, then the values of x, f of x1 is less than f of x2. Okay, هنا الدالة نسميها مضطردة. القيمة الأولى أقل من الثانية تعطينا أن قيمة الدالة عند القيمة الأولى أيضا أقل من قيمة الدالة عند القيمة الثانية. This is the definition of an increasing function. Also, it's important to say that it's increasing in some point, let's say A, okay? So A in the interval x1, let's say that it's an open interval, x1 and x2. It's here increasing, increasing here. This the function in this interval is increasing, so the function f at the element A is increasing. I will always write an arrow to up, going up like that, to denote the increasing function. Okay, now for the decreasing, by the same way, decreasing function, f is decreasing if I have, by the same way, if I have here like that, a function like that, this is an y-axis and this is x-axis. For example, I have here x1 and here I have x2. Of course, by the same way, x1 is less than x2, okay, from the arrangement in the line. دائما هنا العدد اللي على اليسار يكون أصغر من العدد اليمين في أي فترة على الواي axis, على الx axis. On the y axis, the one here is less than by the top one. Okay, okay. Here in the graph, this is the value of x1. Okay, this is f of x1, and this is the value of f at x2. This is f of x2. Which one is greater, f of x1 or f of x2? Notice here, that's the value that I'm talking about. Which one here is greater? Yes, f of x1. It's in the top, so it's the greater. So I write it like that. Notice here, x1 less than x2 implies that f of x1 greater than f of x2. This is the definition of the decreasing function. Okay, هذا الفرق بين الدالة التزايدية والدالة التناقصية. لما هنا الدالة التزايدية لكل x1 أقل من x2 f of x1 أيضا أقل من f of x2. هنا تتزايد باضطراد. وهنا بالعكس، x1 أقل من x2 معناته f of x1 أكبر من f of x2. هذا تعريف الدالة التناقصية أو decreasing function. Also we said here for any element A, sorry, here A is here actually. So here A and f of A at this point. Also here, this is A and this is A, f of A. We said that f of A, f is, sorry, not that, is decreasing at the element A, and A is in the interval x1, x2. Okay. الدالة تكون تناقصية عند العنصر A الذي يقع بين العنصرين أو العددين x1 و x2. Okay. Okay, this is the definition. We didn't miss any information. Okay. Of course, it's not important whether the interval here is open or closed. The most important thing is that the number here is between these numbers. Okay, the interval containing the number A, as we said, or C, like here. And this is the decreasing function. Notice here in this graph, only this part is decreasing, but this part, the first one, is increasing. So I could have actually a function that could increase in some intervals and decreases in other intervals. Okay, ممكن تكون الدالة تزايدية في بعض الفترات وتناقصية في فترات أخرى. Okay. وراح أعرف كيف أتأكد بالتعويض أو بالتطبيق متى تكون بالضبط تزايدية ومتى تكون تناقصية. We will see that later. Okay, now for another definition. Relative or local, this is the same meaning. Maxima and minima. First, what's the meaning of maxima? Maxima is a plural for maximum. A single point, I called it maximum. And the plural اللي هو الجمع أسميها الماكسيما. Okay, هذه more than one point. Minima اللي هي المينيمم point One point is minimum and many points is minima. Okay. Maximum and minimum, I can call them extremum. Extremum اللي هي قيم قصوى. لما أقول لك extremum, I could mean maximum or minimum. قيم قصوى، إما أقصى أو أسفل. أقصى طبعا أعلى عظمى أو صغرى. maximum من القيم العظمى. minimum معناتها القيم الصغرى. Okay. Extremum, as I said, القصوى, could be maximum or minimum. This is just the meaning. Local or relative, قيم قصوى محلية، ممكن تكون في مكان واحد فقط. It's only in some interval. Okay. We will take another kind of maximum and minimum, which is the absolute. The absolute maximum and minimum, which is the most maximum and the most minimum. First, what's the meaning of maximum? If I have a graph of a function, for example, a function is going up in some interval like that. But in some point, let's say here, it changes the direction and going down like that. Okay? So here, the function, let's say that this point is A. The function here, from the beginning until A, is increasing. But from A until the end, it will be decreasing. So here, the point that the function changes from increasing to decreasing, I called it maximum. This is a maximum point. And the opposite for the minimum. If I have here a function, it begins decreasing like that, but in some point, it stops decreasing and start to increase, to up, like this. Let's say that this point is A also. It decreases from the beginning until A and start to increase from A until the end. Okay, so at the point A, the function stopped decreasing and start to increase. So I called A minimum point. This is a minimum. Okay, this is the definition of maximum point and the minimum point. So how to find the maximum and minimum? We will use f dash of x. Okay, first I will find f dash, the derivative, then I will make it equal to 0. I will find the zeros of the derivative. Okay, I called the zeros of the derivative critical points، النقاط الحرجة. أصفار المشتقة الأولى هنا، أصفار المشتقة الأولى أسميها critical points، النقاط الحرجة. If I have the critical points, I make the test. Okay, if the function, for example here, I have the zeros. I have here the zeros of f of a, f dash of a of x. Sorry, from here. If it's first increasing, then decreasing. Here decreasing from on the left and decreasing from the right, then this 0 is maximum. But if I have the opposite, if here I have the 0 or the critical point, if it's decreasing on the left, then increasing on the right, so this 0 is minimum. This is the test or the first derivative test or rule to find the maximum and the minimum point. Of course, this could be only in an interval. That could be only from on an interval. Say that, for example, C, this is the critical point. critical point, and this interval is from A to B. Okay, and also here from A to B. Okay, so this is a
إنك تعيدي
maximum.
آخر حاجة
كيف؟
اللي قبل شوي قلتيها، ممكن تعيدي آخر شيء قلتيه؟
اللي هو ايش؟
هذا الزيروس وهذا.
اوكي، طبعا راح ناخذها بالتفصيل في الامثله الجايه، بس انا راح اقولها بشكل سريع. هو بس السلايد هذه بس للتعريف، بس انا اقول لكم من الحين عشان تركزوا فيها بعدين.
تمام.
how to find the maximum and minimum for a function. First you find the derivative. This is the first thing. Then the second thing, find the zeros. أوجد المشتقة الأولى، بعدين أوجد أصفارها. كيف أوجد أصفارها؟ معناتها أساويها بالصفر وأحل المعادلة. أوجد قيم x التي تجعل المشتقة الأولى تساوي الزيرو. Okay, I find the zeros for the first derivative. The zeros in general called critical points. Okay, أسمي أصفار المشتقة الأولى النقاط الحرجة. بعدين أبدأ أصنف هذه النقاط الحرجة. It could be maximum or minimum or neither. لاحظوا هنا النقاط الحرجة مش شرط تكون maximum or minimum، ممكن تكون فقط نقاط تكون فيها المشتقة تساوي الصفر، لا تكون لا maximum ولا minimum. كيف أعرف إنها تكون maximum or minimum؟ I make the first derivative test. رح نعرف بعدين كيف أعرف تزايدية أو تناقصية، طبعا من إشارة المشتقة. If it's increasing from the left and decreasing from the right, then this zero is maximum. If it's decreasing from the left and increasing from the right, then this zero is a minimum. Okay? This is only the main definition. We will take the details later. Okay? First here, this is the definition, relative maximum or local maximum and minimum. We said that it changes from increasing to decreasing, like this, from increasing to decreasing. So A here is maximum, and here it changes from decreasing to increasing. So here A is minimum value. We said that this definition is for local. It could be only in small interval, but the function here could be have more than one maximum and more than one minimum. Okay, let's say for example that I have a function like this. This could be a maximum, and this also could be a maximum. Notice here that this is a maximum and this is a maximum. But this one, I called it the absolute maximum, and this one is local maximum. It's only from here to here, okay? It's only in some interval, in small interval. But this is the absolute for all the function, okay? For example, here, I have this point. This is the absolute maximum. Since it begins from here, so this is also a maximum, which is the end point, and also this is a maximum, which is another end point, okay? But the absolute maximum is in here. This is the absolute maximum, أكبر قيمة تأخذها الدالة at this point. Also here, this is the absolute minimum, okay? This could be a minimum for or this could be a minimum for a function, but this is the absolute minimum. هذه ممكن تكون قيمة صغرى للدالة، لكن هذه أصغر منها. لاحظوا هنا تغيرت الدالة من التناقص إلى التزايد، معناتها هذه قيمة صغرى. Also here, from decreasing to increasing, so this is also a minimum, but this is the absolute minimum. ما راح ألقى هنا في الدالة المرسومة أمامي إلا هذه الدالة أو أصغر من هذه النقطة للدالة. Okay? The maximum value here at x or at the component, here the y component is 5, so add 5, okay? This is the y component, 5. The minimum value, this is the minimum value, the absolute minimum value at y equals 1. هذا الإحداث الصادي عند الواحد. ممكن أقول إنها النقطة 4 1 أو at x equals 4 or at y equals 1. It will be the same. Also here, I have here a minimum. This is a minimum for a function, but at the end point, the first end point, اللي هي أطراف الدالة, عندي نقطة أصغر منها. This is the absolute minimum. So here the absolute minimum and maximum could be not the critical points. لاحظوا هنا مش شرط أنها تتغير من التزايد إلى التناقص. هنا كانت مجرد أطراف. هنا طرف بس للدالة. It could be an end point. An end point. Okay. ممكن تكون قيمة قصوى تتغير من التناقص إلى التزايد، أو ممكن تكون أحد أطراف الدالة إذا كانت الدالة محددة ضمن فترة مغلقة. Okay, this is here minimum value at y equals 2. And this is a local minimum. And this is local maximum. Okay, here local maximum, local minimum. But this is the absolute minimum, and here some point could be an absolute maximum. Okay, this is the difference between absolute and local. Okay, now for concavity, this is a new definition. What's the meaning of concavity? بالعربي اسمه التقعر. التقعر أو اتجاه التقوس. تقعر الدالة. The concavity of a function, if I have here a function sketched like that, notice here the sketch of a function. I will draw an increasing function. This is increasing, right? As we said. But notice here the concavity. The concavity for the function, I call that it's going up like this. When I said that the function is concave up, this function is concave up. How do I know that it's concave up? I draw a tangent. فاكرين tangent اللي هو الخط المماس. I draw a tangent for a function like this. The tangent لو خط مماس يمس الدالة tangent. Okay. If the function lies above the tangent, then it's concave up. Okay, this is concave up. But if I draw a function like this, this is also increasing. Notice here, I'm not talking about increasing or decreasing. Both functions here are decreasing. This is not my point. But here, if I draw a tangent at any point, of course, if I draw a tangent, okay, here, the tangent lies above the function. So the function is down the tangent, okay? So it's concave down. Here the concavity is going down. This is concave down. Okay? Also, I can also for the tangents, if I draw many tangents at many points, here, of course, all of the tangent will be increasing since my function is already increasing. For example, here, if I draw a tangent at this point, notice here, this is tangent, okay? It have a slope and it's positive. Also here a tangent, also here a tangent. Notice here that the tangent the slope of each tangent is increasing. الميل لكل ما ماس أرسمه كلما اتجهت هنا إلى اليمين يزيد السلوب، يزيد الميل. لاحظوا هنا مثلا هذا الخط تزايدي صح؟ لكن هذا الخط أيضا تزايدي لكن الميل أكبر. هنا الميل لهذا الخط أكبر من هذا الخط مع أن الاثنين تزايديين. Okay? But here each tangent I draw, the slope is going less. Okay? This is another way to know the concavity for a function. It's about the tangent or the slope of multiple tangents. Before we move, how to know or how to find the concavity, of a function, I use the second derivative. Okay, second derivative, I use the second derivative. Then I find when it's positive or negative. If it's positive, so it's concave up. If it's negative, it's concave down at some points, of course. This is how to find the concavity. Of course, we will take some examples later, but this is the main method to find the concavity for a function without a graph, of course. Maximum and minimum, I find it from the critical points. Not all the critical points are maximum or minimum. مش كل critical points أو النقاط الحرجة تكون maximum أو minimum. Notice here that for this function, for example, I could have this function for x to the power 3. هذه رسمة الدالة x تكعيب. At x equal to 0, this is a critical point, but it's not a maximum or minimum. Not a maximum for a function or minimum, okay? Only a critical point, but it's not neither maximum nor minimum, okay? So it could be a critical, but not an extremum value for a function. ليست جميع النقاط الحرجة ممكن تكون قيم عظمى أو صغرى، ومثال على ذلك الدالة x تكعيب. Okay. Okay, this is the concavity as we said. It will be concave up. This is the, if it lies above its tangent line. If I draw a tangent line, the function lies above the tangent line. Or when I draw multiple tangent, the slope of each tangent is increasing, okay? Also here is concave down if it slides down the tangent line, or when I draw multiple tangents, the slope of each tangent is going less. Okay, there's something I called it inflection point. It's related to the concavity. Okay, the inflection point, for example, here I have this function drawing like that. Notice here, it's increasing, but the first part here until this point, notice the concavity. Is it concave up or down? Is this concave up or down? Yeah, yes, it's concave down. Notice here, it's concave down, right? Until this point, it will be changed. Okay. After this point, let's say that it's A. Is it concave up or down? When I draw here tangent, it lies above the tangent. Yes, it will be up. This is down and this is up. This point, A, I called it inflection point. نقطة تحول للتقعر. Inflection point. Okay. Inflection point means that the function changed from concavity up to concave up, here concave down to concave up, or from concave up to concave down. So it could be also like that, concave up until this point, then concave down. Both these functions are increasing. Let's draw something decreasing. Let's say that it's decreasing like that, and it's here concave down. When I draw a tangent, the function lies down the tangent. Until this point, it changes the concavity to up, like this. So here, I called A an inflection point, okay? It changes from concavity down to concavity up, or from concave up to concave down. Okay, this is the possibilities of inflection points. Okay, how to find the inflection point? How to find the inflection point? I find f double dash or second derivative and find its zeros. The zeros of the second derivative could be, it's not necessarily an inflection point. Okay, this is how to find inflection point. We will take examples later how to check if the zeros of the second function are inflection point or not. Now we only take the definition. Also here, notice that this is an inflection point, but the function changes from concave up to concave down, and also changes from decreasing. No, it's all decreasing. Okay, here all decreasing. But when I draw a tangent line, it will be horizontal. Okay, this is a third possibility. Notice also that for inflection point, when I draw a tangent for inflection point, the tangent will cross the function. Okay, the tangent will cross the function. If we here get back to here, if I draw a tangent at this point, إذا رسمت مماس عند هذه النقطة, I will notice that this tangent will cross the function like this. Okay, المماس يقطع الدالة لما أرسمها عند inflection point. Also here, when I draw an inflection a tangent, it will cross the function. Notice that an inflection point is not where a graph changes from increasing to decreasing. لاحظوا هنا أنا ما أتكلم عن تزايد وتناقص الدالة. أتكلم فقط عن concavity. It's only changes from concavity up to concavity down, or the opposite. When I talk about the increasing and decreasing change, I'm talking about the maximum and the minimum. Okay, also about the slope. The slopes are not changing from increasing to decreasing. It only increases in a slope or decreases in a slope. Okay, all the slopes will be increasing or decreasing at the same time. For the first derivative rule, as we said, how to find whether the function is increasing or decreasing. رح نرجع الحين للمصطلح التزايدية والتناقصية. Okay, first, if I want to find whether the function is increasing or decreasing, I find first f dash of x. Second, I find the critical point f dash of x equal to 0. Okay, أول شيء أوجد المشتقة، بعدين أوجد أصفار المشتقة. هذه الأصفار أسميها ال critical points. Okay, then I will classify these critical points. For example, if I have x1, for example, x1 and x2 are the zeros. Okay, then I draw a line like that. Okay, and I point x1 and x2 on this line. This is x-axis, okay, or the line of numbers. Then I test the function at these intervals. Notice here, I have interval, let's say here from minus infinity until x1, and from x1 until x2, then from x2 until infinity. So I have 3 intervals. I make the test of the sign of f dash, okay? I here locate some intervals using the critical points. I have here critical points, so I have now to make the sign test for f dash. أعمل اختبار لإشارة المشتقة. Here I choose some number less than x1 here and substitute in f of x1. If it's positive, if f dash of x1, if f dash of x at some point x here is positive, then it will be increasing. But if it's negative, it will be decreasing. Okay, also here, if it's positive negative, it will be decreasing, and it will, if it's positive, it will be increasing like that. Okay, let's say here that at the same time here I have negative and positive, or positive. Okay, this is possibilities. Okay, for the first possibility, لاحظوا هنا ممكن، هنا احتمالين، ممكن هذا مثال وهذا مثال ثاني. If I have here positive, negative, so it changes from increasing to decreasing. So this is a maximum point, okay? But if it's changed from increasing to decreasing, so it will be like that. This will be a minimum point. But if it didn't change from here negative and here also negative, it's still decreasing. So this is only a critical point. It didn't change sign at each end or each side, or at the both side it's increasing. Didn't change sign. So this is only a critical point. It's neither, okay? Neither maximum nor minimum. اوكي، كيف اعرف انها ماكسيموم او مينيموم؟ اعمل اختبار المشتقه الاولى، اوجد الاشاره، اختار اي رقم هنا من جهه اليسار واعوض. اذا طلعت لي النتيجه موجب معناتها هنا الداله تكون تزايديه، وهنا بعد اعوض باي رقم بين العددين x1 و x2. اذا طلعت لي الاشاره سالبه معناتها هنا الداله تناقصيه، لو كان موجب معناتها الداله تزايديه. اذا كان على يسار واليمين تتغير من التزايد إلى التناقص معناتها هذه النقطة ماكسيموم. إذا كانت تتغير من التناقص إلى التزايد معناتها هذه النقطة مينيموم. إذا كانت ما تتغير الإشارة، يعني هنا سالب وهنا سالب معناتها تتناقص وتتناقص على اليمين واليسار، معناتها هذه ليست قيمة عظمى، أو تتزايد وتتزايد على الجهتين معناتها أيضا ليست قيمة عظمى. عدم التغير في الإشارة على الجهتين معناته أنها إما تبقى تتزايد أو تبقى تتناقص، لا تتغير من التزايد إلى التناقص أو العكس. مجرد نقطة حرجة، neither maximum nor minimum. Okay? Also here a slope for the decreasing or increasing function is positive, and for decreasing function is negative. This is another property. الميل للمماس عند نقطة يكون سالب، هنا يكون سالب لما تكون الدالة تناقصية، ويكون موجب لما تكون الدالة تزايدية. If the question was at a certain point to find the increasing or decreasing معناته أعوض فقط بهذه النقطة. Okay? إذا كان السؤال find if the function f is increasing or decreasing at a certain point A means that I find the function, the derivative of a function at this point and find the sign. If it's positive, then it's increasing. If it's negative, then it's decreasing. Okay? مش شرط السؤال يكون إيجاد النقاط الحرجة أو الماكسيموم or minimum. It could be just find whether the function is increasing or decreasing at a certain point. This is an example. This is how the examples or the question will be. كيف راح تكون الأسئلة على مثل هذه الخصائص أو هذه التعريفات. Sketch the graph. ممكن يكون السؤال sketch the graph. Okay. This could be also a multiple choice. ممكن أعطيك multiple choice مجموعة من sketches and you find the probability. choose the probabilities. ممكن أعطيك sketches وأنت تختار البروبابيلتيز من السكتش المعطى أو العكس or the opposite. I could give you this probabilities and you choose the graphs, the sketch of a graph. Okay, here I will choose these probabilities to sketch a general form for a graph. It should not be a specific points or exact points. هنا مش الشرط اني ارسم النقاط بالضبط او بالتحديد، مش شرط الرسمه تكون جدا جدا دقيقه عند كل نقطه، اهم شيء انها تستوفي هذه الخصائص. Okay, it only should satisfy these probabilities. The first probability that f of -1 is equal to 0. So this is a point that I should draw at a graph. Okay, this is the y-axis and this is x-axis. Okay, and I have here, this is the x component and the y component is 0. So here I have -1 at the x-axis and 0 for the y-axis. So this is the point. This is -1 and 0. Okay, that means that I should have -1 and 0 on the graph. Okay, this is the point. Now I have here probabilities for f dash. Okay, I have here a sign less than 0 for x less than -1. So this is x -1. Okay, for the values here here I have x less than -1 from here, right? Here x is less than -1. For x less than -1, notice here less than -1, I have that the derivative is negative. Less than 0 means that it's negative, have a negative sign. When I have that the derivative is negative, so the function will be decreasing. Okay, decreasing means it's going down. Also here I have that f dash of -1 equals to 0. So -1 here is a critical point. -1 and 0 is critical point. It could be maximum or minimum, okay, or neither. I have here increasing. If it's decreasing here or here increasing, if it's increasing here, so this will be a minimum. I have here that the function here is increasing. Okay, here f dash of x is positive for x greater than -1. Greater than -1 means from here until infinity. So it will be increasing from -1 to infinity. Okay, so I have here to draw a line that cross this point and it's increasing then decreasing, sorry, decreasing then increasing. So I will draw it like this. I don't have any information about concavity or any other information, so I will draw it like this. Here, decreasing until -1. After -1, it will be increasing. Okay, this is the main properties that are given here. The main properties here is that cross this point, and this point is a critical, could be minimum or maximum. And I was given that it beginning with decreasing, then it's increasing. So this is the general or the main property for the function. Okay, this is a sketch of a graph. مش شرط يكون دقيق جدا وأعرف جميع النقاط للدالة. أهم شيء إني أستوفي فقط الخصائص المعطاة عندي. أنا رسمت هنا جراف للدالة أو sketch a graph for a function that satisfies this property. And this is the graph given in the slide. Okay.
Teacher,
أيوة.
the graph comes on the final?
أكيد. ما هو application للديريفاتيف. ممكن يجيك السؤال sketch a graph، بس مثل ما قلت لك إنه مش شرط تكون دقيق جدا. أهم شيء إن الخصائص المعطاة تكون موجودة بالجراف المرسوم. أوكي. الخصائص اللي أقصدها النقاط، إذا كان في نقاط محددة ضروري تكون موجودة. التزايد والتناقص، الفترات اللي تكون فيها الدالة تزايدية أو تناقصية. وبعدين رح ناخذ أمثلة ثانية اللي هي تكون فيها الكونكافيتي. if it's concave up or concave down at certain intervals. تكون معطاة في السؤال. أهم شيء هذه الخصائص تستوفي في مستوفاة في الجراف ويكون الجراف صحيح. ممكن أيضا يجي كمالتيبل تشويس. يعني حتى بالكويز موجود ممكن يكون عندكم سكتش. Okay, by the same way, I will use the second derivative rule to sketch the graph. Okay, to find the concavity. Second derivative helps me to find the concavity. And also I will use it later to find the decreasing or to find the maximum or minimum values by easier way. Now, second derivative rule, if I have a function f of x and I want to know if it's concave up or concave down. How to know these properties? As we said, I will find first f double dash. How to find f double dash or the second derivative? I find first f dash, then differentiate for a second time to find f double dash of x. This is the first step. The second step is to find the zeros of the second derivative. Okay. The zeros here will be a possible inflection point. Okay, inflections point. And I test the sign. Okay, the sign of f double dash of x. If it's positive, so the concavity will be up. It will be concave up. If the sign of f double dash is negative, then it will be concave down. Okay, this is the concavity. So this inflection point could not be in the question. The question could be only find the concavity if it's going up or down. So you will find the second derivative, and in a certain point you substitute and find the sign at this point. If it's positive, it will be concave up, and if it's negative, it will be concave down at this point. Okay. This is the all possibilities for both increasing, decreasing function and concavity, which is concave up and concave down. Okay. The first possibility, of course, if I have here both graphs are decreasing, okay, but here the difference is the concavity. In the concavity, I have here that this is concave up and this is concave down. So here, f dash is positive and f double dash at, of course, this certain point A is also positive. If both first and second derivative are positive at the same number, so it will be increasing and concave up at this point. If the first derivative is positive, but the second derivative is negative, so it will be increasing but concave down. Okay, this is the possibilities for decreasing function. And this is the possibilities for increasing. It could be increasing. So here f dash is negative at these points, at this point here A. But if the f double dash is positive, it will be increasing but concave up. And if double dash is negative, here negative, both are negative, it will be decreasing but concave down. Okay, this is increasing and this is increasing. Okay, هنا بس عشان نفرق بين استخدام إشارة المشتقة الأولى وإشارة المشتقة الثانية. المشتقة الأولى أستخدمها بس عشان التزايد والتناقص، ما عليه من المشتقة الثانية في التزايد والتناقص. المشتقة الثانية فقط تعطيني اتجاه التقوس أو التقعر. هنا تقعر إلى الأعلى لأنها موجبة، وهنا تقعر إلى الأسفل لأنها سالبة، المشتقة الثانية. But both cases here are increasing. Okay? And the same thing here. Both cases here are decreasing, but the difference is the concavity. Here concave up and here concave down. Okay, this is also an example similar to the previous one, but I here have properties about the second derivative. يشبه المثال اللي حليناه، لكن عندي هنا خصائص عن المشتقة الثانية. Sketch the graph of this function f that have this property in the description. Notice here I have a domain or an interval of definition. Okay, f of x defined only for x greater than or equal to 0. So when I sketch the graph, I will only use the x-axis from the right. Okay, only the positive x-axis, including 0. So it will only from 0 to infinity. Okay, this is the domain. Domain of the definition will be the interval. Notice that it's closed since I have here equality from 0 to infinity. This is the domain. Do not draw any values of the function in here. Okay, only begin from this 0. Okay, notice here that it could not be at this point, but I will begin from 0. Okay, and 0 and 0, so it's a point here, 0 and 0. It's given that 0 and 0 and 5, 6 are on the graph. So here given 2 points. Given 2 points on the graph. The first one is 0, 0. I'll draw it here in red. This one is 0, 0. And the second one is 5 on the x-axis. Let's say here 1, 2, 3, 4, 5. This is 5. Okay. And the y component is 6. 1, 2, 3, 4, 5, 6 in here. Okay. This is the 0.5, 6. Okay. So the sketch that I should draw here should be cross these 2 points. Okay, and I begin from this point. Do not draw anything in here. Now, how to sketch the graph? I will use these properties. I here have properties for the function or the first derivative of the function, which is positive. I have here that the first derivative is only positive. I don't have any other sign for the f dash for x greater than or equal to 0. So from 0 to infinity, I have that the first derivative is positive. Okay, so it will be increasing, okay, for all the domain. Also here, I still have to find the concavity. I have here that for x less than 5, okay, here x less than 5 from 0 to 5. From 0 to 5, notice here I don't have equality, so I put here an open interval. The second derivative is negative, so the concavity will be up or down. It will be concave, up or down. Yes, it will be concave down. Concave down, like this, okay? Concave down. And here from 5 until the end, which is infinity, the second derivative is positive. So it will be, yes, it will be concave up. It will be concave up like that. So the point which is 5, the point 5 and 6 is an inflection point. It will be changed the concavity from down to up. This is an inflection point. Okay, كيف عرفت أنها inflection point? Since it changed the concavity from down to up. Okay, so the only remaining thing is to sketch a graph. We will change the color. I will draw a concave down from here to here. Okay, this is concave down. When I reach this point, I will change the concavity, but still increasing. Okay, I will only change the concavity. So here it will be concave up. Okay, let here the graph be smooth. خلي هنا الجراف يكون أملس من غير أي زوايا. It will be only an inflection point. Okay. Notice here that this is increasing and this is increasing, but the only difference is the concavity. This one is concave down and this one is concave up. فقط هذه الخصائص المطلوب أني أرسمها في الدالة.
السلام
أهم
عليكم.
شيء وعليكم السلام.
معلش المقاطعة دكتورة.
تفضل.
علي كويز اسمحي لي أستاذن إذا ما عليك أمر.
تفضل.
الله يعطيك العافية.
Okay, so I just have to indicate the inflection point, that this is an inflection point and the domain begins from 0 to infinity, and from 0 to 5 it will be concave down, and from 5 until the end it will be concave up. This is the main properties that I have to sketch on the graph, nothing else. Okay. And it's similar to the graph that is sketched in the original slide. Okay, the first derivative test, we did it, or I said it before for you. I will repeat it again. The first derivative test means that I will find f dash of x, the first step. Then I will find the zeros, the zeros of the first derivative, which gives me the critical point. Critical points. Okay, these critical points could be maximum or minimum, and it's also could be neither maximum nor minimum. Okay, how to find maximum or minimum? As we said, we investigate the sign of the first derivative. أتحقق من إشارة المشتقة الأولى. If at this point, for example, critical point A, if the function changes from increasing to decreasing, so this will be maximum. And if it's changes from decreasing to increasing, so this critical point will be minimum. And if it didn't change the sign, it could be increasing at the both side. This will be neither maximum nor minimum, or it could be negative, decreasing. It will be also neither. Okay, this is the first derivative test. This is the case that a critical point like here A is neither. Okay, it is still here decreasing or still increasing or still decreasing, even though this is a critical point. Okay, this is the three possibilities for critical points. Now let's take an example. أيوة.
For function x cube, it's increase also. It's neither.
Yes, it's neither. For I have here x cube. It will be draw a sketch. Sorry, like this. Okay, cubed or to the power 5 or any other odd exponent. If I have f dash of x, it will be 3x squared. When I find the zeros, x equal to 0, right? But the graph, I notice here that it's here increasing and increasing, though this is a critical point. Okay, so it have a critical point at x equal to 0, but it's neither maximum nor minimum. This is an example. Okay, now let's see this example. Find local maximum and minimum. When I said local, it didn't make any difference. Okay, I will just find the first derivative and make the first derivative test. Okay, and it will be local maximum or minimum. But if the question finds the absolute, I should choose the maximum value. أختار القيمة أكبر قيمة ممكنة تأخذها الدالة. But local and local, if I said local or relative, it will be the same procedure. أتبع بس نفس الخطوات، أوجد المشتقة وأختبر الإشارة. Okay. So here I will take this function, the first step, as we said, I will find the first derivative, f dash of x. The first derivative will be here 6x squared minus 6x minus 12. This is the first derivative for this function. Okay. Then I will find the zeros. F dash of x equals to 0. This is the second step, means that I will find the zeros of this equation. I will solve this equation. 6x minus 6x squared minus 6x minus 12 equal to 0. I can simplify here. Divide by 6. I have x squared minus x minus 2 equal to 0. Right? So I can use the quadratic formula, x equal to minus b, which is 1, plus or minus square root of b square 1 minus 4ac multiplied by minus 2 divided by 2 equals to 1 plus or minus square root of 1 plus 8, which is 9, 1 plus or minus square root of 9 over 9, sorry, here over 2. Which is 1 plus or minus 3 over 2. Which one minus 12? Minus 12. Do we have mistakes here? Which one is minus 12? What do you mean by this? Here I have 6 minus 12. لا مش هنعوض عن x بصفر.
سؤال بس يا دكتورة.
كيف؟
سؤال minus 5 وين بتروح السؤال؟
قصدك هذه؟
أيوة.
بلس 5 اشتقيتها. مشتقة العدد الثابت تساوي الصفر. هذه عملية الاشتقاق لكثيرة الحدود. أنزل الأس وأضربه بالمعامل وأنقص من الأس 1. هنا minus 12x مشتقتها only minus 12 ومشتقة الخمسة بالصفر. معناتها ما راح يكون في المشتقة في هذا الحد. So here plus 0. Okay. So here I will have two points, which is 1 plus 3 over 2 and 1 minus 3 over 2. Okay, so it will be 4 over 2, 2, and minus 1, sorry, minus 2 over 2 minus 1. These are 2 points, right? So I have here 2 critical points, x1 equal to 2 and x2 minus 1. These 2 critical points. How to find the maximum or minimum? As we said, we draw the line of numbers, and indicates these points. I begin with the smaller one, which is minus 1, then 2. Then find the sign of the function or the derivative f dash of x. Okay, I choose any number less than minus 1 in this interval. اختار أي عدد هنا في هذه الفترة يكون أقل من سالب الواحد. أوكي، هنا راح أختار السالب 2. I will choose minus 2 to substitute in f dash. لاحظوا هنا أني أوجد إشارة f dash مش إشارة المشتقة. أوجد إشارة f dash عشان أوجد إذا كانت موجبة أو سالبة. أعوض في المشتقة مش في الدالة. To find the sign of derivative, to find the decreasing or decreasing interval. So here, if I choose, for example, for x equal to minus 2, ممكن أنتوا تختاروا أي قيمة ثانية. I will choose, بالنسبة لي أنا راح أختار x تساوي سالب 2 وأعوض في المشتقة الأولى. x equal to minus 2. If I substitute it here, what will be the value? F dash of x equals to 6 multiplied by minus 2 square minus 6 multiplied by minus 2 minus 12. What's the value? Okay, 24. It will be positive, right? So the function, the derivative here is positive. Okay, all the value here at the left will be positive. So the function here will be increasing, okay, for all this interval. For the second interval, from minus 1 until 2. I choose any number between these two numbers to find the sign of f dash. The easiest one is 0. اوكي راح اختار هنا بين الاعداد السالبه والموجبه، من الاسهل دائما اني اختار الصفر. اوكي I will choose here for example x equal to 0. f dash of 0 will be 0 minus 0 minus 12 minus 12. So here it will be minus for f dash. F dash will be minus. Okay, I'm talking here about the sign of f dash. So the function here will be increasing, okay, for all values between minus 1 and 2. Now for the values greater than 2, I will choose any value, اختار أي رقم greater than 2. For example, x equal to 3. Okay, هنا راح اختار x equal to 3. Yes. So f dash of 3 will be, okay, someone find the value here. 6 في 3 تربيع ناقص 6 في 3 ناقص 12 كم تطلع؟ Okay, it will be also 24. Okay, 24 or minus 12. Let's check. Here 6 multiplied by 9, which is 36. No, 6 multiplied by 9.
27.
Yes. Then minus 6 multiplied by 3, which is 18 minus 12. 6 multiplied by 9 is 50.
54.
54, right. 54 minus 18 minus 12. It's obvious that it will be positive, right? أتوقع أن مجموع هذين أو 18 ناقص
24.
it will be 24. So it will be 24, it will be positive. هو مش مهم القيمة، أهم شيء الإشارة. أتأكد أن الإشارة موجبة أو سالبة. So it will be positive for all values here. So it will be increasing. Okay, so this is the main properties that I should know about the function to know the maximum and minimum values. So here I will just classify the function, classify the values. Okay. Since here the function changes from increasing to decreasing, so this point will be maximum, and here at this point it changes from decreasing to increasing, so this point will be minimum. So at x equal minus 1, f of minus 1, هنا الغرض اني اوجد الاحداث الصادي. I will find the y component to indicate the point. f of minus 1 equals to, أعوض وين? I will substitute in the main function. Okay, it will be 2 multiplied by minus 1 to the power 3 minus 3 minus 1 square minus 12 minus 1 plus 5. Okay, it will be equal to minus 2 and here minus 3 minus 12, or here minus plus 12 plus 5. هنا يهمني النقطة بالضبط تطلع كم عشان راح أحددها أو I will indicate the point. Okay, it will be 7. So here the point will be.
It will be 12.
كيف؟ It will be the point minus 1 and 7. Minus 1 قلنا this is minus 1. It will be a maximum. Is a local maximum. Okay. Also, I will find f of what's the second point? It's 2. Okay, I will find the value of x at 2 to find the y component, which is 2 multiplied by 2 to the power 3, which is 8 minus 3, 2 square minus 12 multiplied by 2 plus 5. كم راح تطلع؟ 21. So the point 2 and 21, it will be not 21, check the point. It will be minimum, local minimum. Local minimum.
دكتورة في الأخيرة في أي معادلة عوضنا؟
هنا عشان أوجد الواي كومبوننت أعوض في المعادلة الأصلية، عشان أحدد نقاط بالضبط، عشان أوجد إحداثيات صادية أرجع للدالة الأصلية. متى أعوض في المشتقة؟ عشان بس أوجد الإشارة للمشتقة وأحدد التزايد والتناقص. لكن لما أبغى أحدد نقاط أوجد إحداثيات صادية أرجع للدالة الأصلية قبل الاشتقاق. minus 15.
دكتور
أيوة.
minus 50.
Okay, minus 15. Okay, I don't have calculator next to me, so I depend on you.
Yeah, Doctora, it's not 7. It's 12, I think.
هذه بعد?
Yes, because
Okay, here.
minus 5 plus 5, 0, and it will be
Yes.
12.
It will be here. Right, it will be 12. 12, right?
No, I think because you in the first, you put 2, multiply by minus 1, right?
Yes, this is minus 2. هذه كلها minus 2. And this minus 1 square is plus 1. So this is minus 3. This is minus 3. Minus 12 multiplied by minus 1 plus 12. And this is plus 5. Right? I think the value is really 12. This minus 5 plus 5, 0. So it will be plus 12. We will check it later in the next slide. طيب هذه القيمة كانت كم؟ minus 15. Okay, here minus 15. We will check it later and the later in the next slide. Okay, this is minus 15. Okay, the point minus 2 and minus 15 is local, as we said, minimum. Okay. Yes, here for 12 for the first one and minus 15 for the second one. Okay, notice here the graph of the function. I indicate the point. Okay, I indicate the point. Notice here, this is minus 1, the first one, minus 1 and 12. Okay, this is the point minus 1 and 12. I said that it's a local maximum. So I begin here from minus infinity until this point with an increasing graph. Okay, if I reach here, I begin to decrease the function until this point, which is 2 and minus 15. معناته أول شيء أحدده هنا في الجراف هي هذه النقطتين. طبعا هنا مش مطلوب مني في السؤال sketch the graph، هنا فقط للتوضيح. أو ممكن لو جاك السؤال إن sketch a graph of this function using the first derivative properties. Okay. So from
Why it's local, why not absolute?
هنا لاحظة ممكن هذه النقاط مثلا عند هذه النقطة لما أجي أقارنها بهذه النقطة هذه أقل، مع أنها مجرد end point، مش شرط تكون critical point تكون بهذا الشكل. عرفتوا؟ مش شرط إنها تكون okay got it. ممكن تكون الابسولوت مينيموم والماكسيموم تكون الend points للدالة. Okay, so I called these locals. Okay, الدالة ممكن تغير من التناقص إلى التزايد في نقاط معينة، لكن كقيم عظمى ممكن تكون لها قيم عظمى في نقاط أخرى، لكن لا تغير من التناقص والتزايد فيها. اوكي ممكن تكون هذه القيم العظمى والصغرى at the end points. Okay. As I said, it decreases from -1 until 2, from here until this point, decreasing. So I stop decreasing here and begin to increase until infinity. Notice here from minus infinity. So this will be continuous. Okay. Now for the second derivative test, it will be exactly the same, but we will investigate the concavity for the function. Okay. If it's, of course, I will find the second derivative first. This is the first step. The second step is to find the zeros of the function or the second derivative. If it's positive, and find the zeros, and if it's positive at this point, it will be concave up, and if it's negative, it will be concave down. Okay, this is about the concavity. There is another use for the second derivative. I call it the second derivative test. Okay, this is concavity. Okay, here I can find if the point. If I have a point, for example, x equals a, if it's maximum or minimum, I can find whether it's maximum or minimum using f double dash of x. I will make the second derivative test. Okay, I will find f double dash at this point a. Okay, A is a critical point. Okay, A is a critical point, not inflection point. Okay, this is not the zeros of the second derivative. This is the zero for the first derivative. Okay, this is a critical point. If the second derivative at this point is positive, it will be a minimum. Okay, and if it's negative, it will be maximum. Okay, notice here I'm talking about maximum and minimum, but I'm using the second derivative. Okay, where did I get this from? Notice here that for minimum, it will be drawn like this, right? This is a minimum. Notice the concavity, it will be concave up, right? The concave up means that f double dash is positive, right? But for the maximum, okay, this is a maximum point. This is a maximum point. The concavity here is down. So I expect that f double dash will be negative. Okay, negative sign. So I make the second derivative to find the minimum and maximum using the concavity. Okay, the maximum point is concave down, so it will be negative for the second derivative, and the minimum will be concave up, so it will be a positive. Okay. Of course, this test could be failed if I have, for example, f double dash at this point equals to 0, the test fails. For example, if I have x for the function x to the power 3, okay, at x equal to 3, it will be a critical point, but neither maximum nor minimum. I can't use the second derivative test. Okay, this is the slide. As we said, I use the first derivative to find the critical point, then substitute these values in the second derivative and find the sign. If it's positive, it will be minimum. If it's negative, it will be maximum. And we will apply some example. The question is, locate all possible relative extreme points. What's the meaning of extreme point? We said in the first of this lecture, in the beginning of this lecture, that extremum or extreme points, قيم قصوى. It could be minimum or maximum. Okay, what I mean by extremum, minimum or maximum points. Locate all possible minimum points. أيوة اللي هي القصوى. On the graph of the function f. This function is given, which is x squared plus 6x x cubed by 6x squared plus 9x. Check the concavity at these points and use the information to sketch the graph. So I have also to sketch a graph. First question, find the extreme point, then check the concavity, then sketch a graph. 3 questions. Okay. Okay, I will begin with extreme points. For the extreme points, I will find the critical point. Okay. If dash of x equals. Here, the derivative, if I differentiate this function, will be 3x squared plus 12x plus 9. I have here 9x plus 9. Okay, then I find the zeros of the first derivative. Here I will use, first I will divide by 3. Okay, I will solve this equation. So I will divide by 3 to simplify. I will have x squared plus 6x plus 3 equals to 0. Okay. I will use the quadratic formula, x equal to minus b plus or minus square root b squared is 36 minus 4a t is 3 divided by 2. Oh, sorry, here divided. Sorry. Okay, I make a mistake here. I divide here by 3, so this should be 4. Okay, thank you for notice that. Here 4.
Doctora, can we make the symbol? It will be 3 and 1, يعني x plus 3 and x plus 1.
ممكن إذا كانت قابلة للتحليل ممكن أحللها، بس أظن أن هذه غير قابلة للتحليل.
If it's 3 and 1, for plus it will be 4, and when we نضربها تصير 3 ولا؟
ممكن أستخدم اللي هو الفactorization. If I use the factorization, just I will correct here, make correction, will be minus 4. I can here write x and x, here 3 and 1. If I add 3 and 1, I will have plus 4, and when I multiply, I will have 3. So here plus and plus will be 0. So here I have x equal to minus 3 and x equal to minus 1. Right? It will be the same when we use the quadratic formula. Okay, we will use these points. I will erase this. You can use this, of course. If you didn't, you're not sure about the factorization. Okay. Relative extremum or local extreme points. I will use the second derivative test. So I will begin with x equal to minus 3. Okay. I will find first the second derivative to substitute with these numbers. it will be 6x plus 12, right? I differentiate for the second time, I differentiate the first derivative. So if double dash of the first one, which is minus 3, here minus 3. Okay, and find the sign. The most important thing for me here is the sign. Equals to 6 multiplied by minus 3 plus 12 equals to minus 18 plus 12. It's obvious that it will be
minus 6.
Yes, it's a minus 6, which is negative, right? Negative sign. Okay, if the second derivative is negative, so the concavity will be down and the value will be maximum. So at x equal to minus 3 will be maximum. Also, if double dash at the second point, which is minus 1, will be 6 multiplied by minus 1 plus 12, which is minus 6 plus 12. I add these together will be plus 6. Yes, plus 6, which is positive. So at x equals to minus 1, it will be minimum. Now, to write my answer, correct answer, I have to find the y component. Okay, the exact point. So it will be minus 3 and f of minus 3 and minus 1 with f of minus 1, and say that this is maximum or local maximum and this is a local minimum. Okay, here to find this f of minus 3,
It's minus 6.
minus 6 هنا. Okay, minus 6 and minus 1, if I substitute here minus 1 plus 6, which is plus
6.
5. أكيد. Okay,
Plus 6.
Okay, plus 6. And this will be the maximum and this will be the minimum. Okay, I will keep this point to use it later in the graph. Okay, I will erase now some of this to complete the solution, and I will keep this. Okay, I will check the concavity, so I will keep also the second derivative. I don't need this. Okay, now for the second question which is check the concavity. I will check now the concavity. For the concavity, first I have to find the inflection point. Okay, the second question is to check the concavity. So I have to find the inflection point. I have to find the zeros.
Doctor, I think the point is not right. We just make it with the F dash. يعني عوضنا في ال F dash. المفروض نعوض في الدالة الأساسية صح؟
عندك اتصال صح؟
الو
اتوقع انه طلع الدكتور. طلع
ايش شكله علق.
علق عليها وطلعها.
لو سمحتوا ممكن نطلب منكم طلب؟
قول يا الأخو.
دحين عندي اختبار، ولما تيجي المس قول لها شو اسمه ده، في واحد طلع اسمه عبد الملك عنده اختبار. تمام؟
أنا أتوقع إنه
ماشي حبيبي، توكلنا.
ها؟
ما أتوقع إنه بتنقص أحد في الحضور، لأنه معروف إن الناس عندها كثير، لأنه مو الحالة أصلا.
وقتك يقطع.
Okay, I'm back here. Sorry. معلش بس قطع عندي.
مس
أيوه.
أنا خارج، عندي اختبار دحين، عندي كويز.
طيب مو مشكلة.
ثانك يو.
Okay, معلش إيش آخر شيء سمعت؟ قطع.
بعيد يا دكتورة،
كيف؟
صوتك بعيد.
Okay. Okay, I think you all see the maximum and minimum that we found. First step, we found the extreme points. أوجدنا الماكسيموم والمينيموم.
دكتورة.
The second derivative test. أيوة.
I think the point is it's wrong because إحنا نعوض في أي دالة، في الأولى ولا في الإف-داش؟
أنا أخذتهم لا، هو المفروض إن أعوض هنا هذه النقاط، أعوض في الدالة الأصلية اللي هي هذه.
أيوة، ما راح يطلع minus 6 and 6. نحن عوضنا في
صح.
الدالة اللي بعد الاشتقاق.
عوضنا في المشتقة الثانية.
راح
لا،
تصير
عوضنا في
سالب
في
3
الدالة
أو
الأصلية.
0. سالب
عشان
3
أوجد أي
و0
نقاط.
سالب
معلش
1
اسمعيني.
سالب 4.
أوكي، عشان أعوض أو عشان أوجد نقاط هنا، أوجد إحداثيات صادية، أي إحداثيات صادية أعوض في الدالة الأصلية، ما تعوض لا في المشتقة الأولى ولا في المشتقة الثانية. فهنا المفروض كم تطلع؟
سالب 6 غلط.
كيف؟
سالب 6 غلط.
Okay, what's the correct answer?
0.
0.
Yes.
ما أعوض هنا، أعوض بهنا x to the power 3. أوكي، راح أعوضها هنا اللي هي سالب 3 أس 3 زائد 6 سالب 3 تربيع زائد 9 مضروبة في سالب 3. هذه كم تطلع؟ أكيد 0. سالب 3 زائد 6 في 9 اللي هي 54 ناقص 27. هذه كم تطلع؟ مش 0. سوري، هنا سالب 3 تكعيب اللي هي 27. سوري. So this 27 زائد 27 54. صح، 0. معلش هنا 0. Okay, minus 1. Also minus 1.
It will be minus 4.
minus 2.
Minus 2.
4.
minus 4.
Minus 4. Okay. Minus 4. This point I will indicate it in the graph as a maximum and minimum points. Okay. Okay. تذكروا دائما أن أي إحداثيات صادية أعوض في الدالة قبل الاشتقاق، الدالة الأصلية. أما المشتقة الأولى والمشتقة الثانية أعوض فيهم بس عشان أحصل على الإشارات. اللي يهمني هنا من المشتقة الأولى والثانية لما أعوض فيهم أحتاج الإشارات فقط. Now for the second part, which is the concavity, I need here to find the concavity of the function. So I need the inflection point. How to find the inflection point? I will use the second derivative and find its zeros. So I have here 6x plus 12 equals 0. it will be 6x equals minus 12, x equals divided by 6 for each minus 2. So minus 2 could be an inflection point, but I have to check. I have to check the sign of f double dash at the left and at the right of this point, okay? So I indicate the point minus 2 and check the sign of f double dash. I choose any number less than minus 2 and substitute here. أختار أي عدد أقل من سالب 2 وأعوض هنا عشان أعرف الإشارة فقط. For example, for minus 3, f double dash of minus 3 is 6 multiplied by minus 3 plus 12. It will be minus 18 plus 12 will be negative, right? Here it will be negative. So it will be concave down, okay, at this interval. Okay, after minus 2, the easiest value will be 0. So I will substitute here with the 0. 6 multiplied by 0, 0, so it will be plus 12. It will be here positive. So it will be here concave up. So this is an inflection point. So at minus 2, and I will find the y coordinate here, is inflection point. Okay, I need here the y coordinate for minus 2. I substitute here minus 2 to the power 3. كم يطلع؟ 6 multiplied by minus 2 square plus 9 multiplied by minus 2. It will be minus 8 plus here 4 multiplied by 6, 24 minus 18. كم؟ Okay, minus 2. You're sure minus 2? Here
Yes,
minus. Okay, here أيوة 26 ناقص 24 minus 2. Okay, minus 2. This is an inflection point. Okay. Now I will arrange all these. Okay, here minus 2 and minus 2 will be inflection point. Inflection point. It will be first concave down, then concave up. I will use all this information to sketch a graph. Okay, an approximate graph. Okay, مش ضروري يكون جراف دقيق. Approximate graph. I will keep this information to use it. Now I will use my information. Okay, I will first draw the y-axis and the x-axis like this. Okay, then I will indicate these points. Okay, بس خلينا أتأكد بس. هنا جميع القيم سالب 3 و0 سالب 1 سالب 4 والانفليكشن بوينت اللي هي عند السالب 2. Okay, now to complete. بس عشان نتأكد إن جميع نقاطنا صحيحة. I will indicate these points first. أول شيء سالب 3 و0. First سالب 3 minus 3 and 0. Y coordinate is 0. So here minus 3 and 0. It will be maximum. And minus 1. This is minus 1 and minus 4. So 1, 2, 3, 4. This is minus 4. Minus 1 and minus 4 at here. Okay. I said that this is maximum and this is minimum. Also, I need this inflection point, which is minus 2. Could be here. Okay, this is inflection point at -2, -2. Exactly at this point. -2 and -2 inflection point. So I begin here. Since this is maximum, so the function will be increasing, then decreasing. Like this. Notice here that this is increasing until here, then, and we said that it's concave down. So I keep it here like this, concave down. Okay, concave down. And here also concave down, but decreasing, sorry. Until the inflection point, it will still decreasing, but the concavity will be changed. Here will change the concavity to up. So here until -2 and -2, I will change the concavity to concave up. Okay. Until this point, I said that it's a minimum, so I stop here and start to increase the function. Okay, I will increase the function like this and keep the concavity up. It will be concave up. Okay, this is an approximate. هذا رسم تقريبي مش دقيق طبعا. An approximate sketch for this function using the concavity and the extreme points. Okay, and it's similar here to this sketch. Okay, the last thing that we'll discuss here, the test of an inflection point. Like in the previous example, we find the zeros of the second derivative for possible inflection points. Okay. Okay, the final example. I will just solve this example and stop. I'll just check the recording. Still recording. Okay, we'll sketch this graph. The main important thing is I will find first the maximum and minimum values. So I will find first the critical points. This is the first step. The second step, I will use the second derivative test to find the minimum or maximum. Also, I find the second derivative test equal to 0 to find the inflection point and concavity. Okay, this is how to sketch a graph. Also, something maybe I could use, which is the y-intercept. Y-intercept اللي هو المقطع الصادي، نقطة التقاطع مع الصادات, and x-intercept. This could be useful also to draw a graph or sketch a graph. Okay, it's not important, but it could be useful. First, I will use this function to find the first derivative. As we said, I will find the critical point f dash of x equals to 3x squared minus 1. This is the derivative, right? This is the first derivative. I will find the zeros. The zeros here is easy to find, which is 3x squared equal 1, dividing by 3. It will be x squared equal to a third. I will take the square root, so it will be plus or minus 1 over square root of 3. Okay? Or the square root of third. I take the square root of the both side. I can set the square root of third, or ممكن أطلع الواحد برا الجذر، جذر الواحد بواحد، واحد على جذر الثلاثة. Okay. So I have here 2 points. I have to check whether these are minimum or maximum. So I will use the second derivative test. Okay, I will find the second derivative, which is 6x. First, for x equals plus 1 over square root of 3, f double dash is 6 multiplied by square root of 3. The most important here thing is the sign, which is positive. So here, it could be concave up or concave down, so it will be concave up. It will be minimum. Okay, this is a minimum point. And also, I have the second one, which is minus 1 over the square root of 3. Notice here, I have a plus or minus. So the second derivative test, I substitute in the second derivative with minus 1 over square root of 3. It will be minus 6 over square root of 3. It's negative. Okay, so it will be a maximum point. I find now the maximum and minimum point. So, and now I need the inflection point and the concavity. I will use the second derivative, f dash of x, which is 6x, and find the inflection, the possible inflection point. I will make it equal to 0 and find the zeros. It will be 0 at x equal to 0. Now to test the concavity, will be here at x equal to 0. I choose any negative number here and substitute it in the second derivative. It will be minus, and I substitute any positive number here, it will be positive. So here concave down and here concave up. So this is an inflection point. Okay, this is inflection point. I need the y coordinate. If I substitute with 0 in the main function, 0 and 2, an inflection point. Wait, this is an inflection point. I will use it in the graph. Also here, the maximum and minimum, I said that this one is minimum and this one is maximum, local maximum and local minimum. I need the y coordinate. I still here need the y coordinate. I will just erase this, make a space. خلصت المحاضرة. اللي ممكن اللي عنده شيء ثاني يقدر يتفضل، بس أنا راح أكمل فقط السكتش لهذا المثال. Okay. Okay, we still need here the y coordinate. So I need f of 1 over square root of 3 and f of minus 1 over square root of 3. ممكن تحصلوا تسجيل المحاضرة على LMS أو أرسل لكم بالإيميل. Okay, and you will find the value. Okay, and I will use these values. Okay, I will take it immediately here without notice here that the same value. العدد اللي أنا كتبته اللي هو 1 على جذر 3 هو نفسه جذر 3 على 3. أوكي، بس هنا مثل عملية انطاق المقام أو الضرب في المرافق هي نفسها. راح آخذ القيمة اللي هي 18، واحدة ناقص 2 جذر 3 على 9، واحدة زائد 2 جذر. اختصار. Okay, it will be 18 plus or minus with the first one. 2 جذر 3 على 9. 18 minus 2 جذر 3 على 9. one of them was minus. Positive minus, and this will be negative. Okay. This is the y coordinate. So in the graph, I will indicate these points. Okay. أحسب هذه القيمة بالآلة الحاسبة وأحدد الواي كوردينيت للواحد على جذر الثلاثة أو جذر الثلاثة على الثلاثة، ونفس الشيء هنا أحدد هذه النقاط وتكون هي المينيموم and maximum. Okay, minimum and maximum. So the function will be we'll take the location. Okay, one of them will be here, and the other will be here. Okay, the first one, and here minus will be, this was maximum, and the second one will be minimum, and I have an inflection point at 0, 2, 0, 2 here. This is 0, 2. So here maximum, then minimum, and the concavity here will be down until this point, then concave up. Sorry, here it's inflection point, not, yes, would be like this. It's still decreasing. I should here lower this point like this. Okay, or lower this point.
الدكتورة أتوقع راح تكون 7/10 وسالب 7/10 يعني بعد الفك الجذر.
اللي هي الواي كوردينيت ولا الاكس كوردينيت؟ تقصدي هذه صح؟
أيوة.
الأولى كم؟
الأولى 0.7.
هذه 0.7
تقريبا يعني إيه.
Okay, approximately. This one.
1 minute.
أيوة تقدر تطلع، خلصت المحاضرة.
It will be minus 0.7.
minus هي المفروض بالبوزيتيف. أسماء notice here positive y axis، هذه positive. تأكدي من الإجابة. أول شيء هنا اضربي واضح إنها بوزيتيف أصلا، هذه لازم تكون بوزيتيف، إنها 18 موجبة وهذه موجبة تقسمها على موجبة، هذه ضروري تكون موجب.
Sorry, it will be 1.08.
1.08 approximately. Okay, so okay, this just to draw this. عشان تكون القيمة أقرب. هنا قلنا for example هنا لو قلنا إن هذا هو السالب 1 على جذر 3 وهنا موجب 1 على جذر 3. Approximately here 0.7. So at this point local maximum and here local minimum or the opposite. معناتها الأولى لا صح، هذا اللي هي 1.08. So here 1.08. صح إجابتك كانت تقريبا هنا 1.08. هذه هي الماكسيمم والمينيمم اللي هي 0.7 تكون تقريبا هنا. وهنا اللي هي 0.2 هذه النقطة اللي هي 0.2 الانفليكشن بوينت. أبدأ دالة هنا تكون تزايدية إلين أوصل إلى الماكسيمم until I reach to the maximum, then decreasing until the point 0.2, which is here, for example, sorry, here, until here, this is 0.2. Then I will only change the concavity. Okay, I will here concave up until this point, then start to increase. Okay, الدالة هنا تبدأ تتناقص but concave down until this point, which is the inflection point, then concave up. Okay, until the minimum, then it will be increasing again. كده نكون خلصنا الجراف للدالة, or we sketch the main properties of the graph. Okay, we use the same information here. Okay, and we finished. Okay, we'll complete in the next lecture. اللي مو موجود بالشعبة ويبغى تسجيل المحاضرة ممكن يحصل على LMS.